All right, so there is there's a little antiderivative deal with arc sine. Okay, so what you need to do, and Mary, I think, asked a very good question. Why aren't we just doing the, 1 minus 4x squared to the negative 1/2 power and going from there? And the answer is because that wouldn't work. Because you might try and do u substitution as 1 minus 4x squared, but then when you take the derivative of that, the du, you would get negative 8x, and there is no x in there, so you can't do that. So you have to sort of recognize this as being a inverse trig function type of question. You sort of have to see that. Just like Jefferson got really good at the taking the integral from negative pi over 6 to pi over 6, and he goes 0 because it's a symmetry thing. You just have to see that. Okay. Sure. Would you like? Okay. I'll give you a second to work through this one on your own. It's actually that's fine. You're giving up to yourself from now on. All right. So the great part of this, the problem is it's 1 over x squared plus 1, right, is what we're looking for, but we have an a squared. So the way that we are going to turn that a squared into a 1 is we are going to factor an a squared out, and that will make that into a 1, okay? When you do that, though, what does the x squared become? Right, x squared over a squared, all right? But we are okay. Yeah, is that your word of the day or something? Why don't you stop saying that? Because this is on the bottom, and I know this bothers you a little bit, but it is a constant. You can pull that out, okay? So I can rewrite this as 1 over a squared times the antiderivative of 1 over x squared over a squared plus 1 dx, okay? So look at what I did there for a second. Yeah, I'm not going to do anything, okay?
So I did recognize this as a key.
Right, that's what we're trying to get to, yeah, so that's a good key, yeah.
So,
Okay, hold on. Okay, so everybody's good? Okay, so Mary,
so when you get rid of that a squared on the bottom.
this thing right here.
No.
Well,
We'll
yes,
make
yeah.
that a u.
Okay, so let's try her method here. We would like to make this be u squared, right? So u squared equals x squared over a squared, okay? Because then we can write this as 1 over a squared times the antiderivative of u squared plus 1, which is exactly what we want, except we still need to change this dx into something, okay? So if u squared, we're going to find that in a second, if u squared equals x squared over a squared, then that means that u equals x over a. Are you good there? Okay. If I know that u squared equals x squared over a squared, and you said what's our du, so to get our du, I need my u first. So I took the square root of both sides. Okay, good. All right, so now that we know what u is, such bad grammar, what you are, I can take the derivative of that, which is, no, because this is a constant. What? No, what did you say? Oh, 1 over a, yeah. Dx, okay? She's being a ventriloquist. She made it sound like Mary
So
said.
then on the outside it's 1 over a cubed.
No. If I need to balance out this 1 over a, remember I have to do the opposite, right? So it's right.
A to the negative first.
Yes, so I'm going to have an a right here, okay? To get rid of this a right here, and then I have a dx. I mean, not dx. Oh, sorry, du. Sorry. Right. Okay, so before I do that, though, let's make sure that you...
So is that an a times that's times?
Yes, because I needed to multiply this by a and multiply this by a to get rid of those a's there. So a du equals d. Okay? Remember, this is exactly the same as on this last problem. I had a 2 in front, So I wanted to get rid of that 2, so I put the inverse 1/2 on the outside, okay? So this time if I have a 1 over a, I have to do the inverse, which is an a, okay?
So
All
now
right.
we do
Hey,
the,
right, now counter points out that these are going to cancel.
yeah.
So I get, well, a over a squared is just 1 over a. So that makes this look like that.
Can you do the tangent switcheroo thing?
Yep, now I'm going to do the tangent switcheroo thing. So this is 1 over a times the inverse tangent of u. Okay, and then we need to, this is an indefinite integral, so we have no choice but to substitute the u back in there. So my final answer is 1 over a inverse tangent of x over a, yep, plus c.
So,
And
Final
then
answer.
you
you
don't
just
have
put-
an interval.
And we did the integral, so we're done with that. Okay. Last
that made sense. That was intense, but I mean,
What you got there?
that's happening.
Okay. All right, this result, they love so much that they would like to highlight it for you.
Okay.
That the antiderivative of 1 over x squared plus some number squared equals 1 over that number inverse tangent.
I'm just gonna draw some
So
squares.
I would put that on your note card.
Go on my note card,
Yeah, if they box it like that, that's good.
but not always.
Not always,
Say,
not always.
um,
This is a good one. Seems like it. Got it?
No. Oh wait, you can change it because I have it on my paper. I hope I'd be able to do this again.
Well, we're about to find out.
Okay.
We got one more page, got one more try.
One more page. Oh, wow. I like this one. Really not through 18 pages. This is better than what we did the other day.
We did the first half, like,
Yeah, I didn't like the first half.
the derivatives, you don't like this. I think I told you the story already, but I randomly played golf with some guy that I didn't know, and we were chatting, and I told him when I was a math teacher, he said, I got as far as calculus. I learned that calculus was 2 things, derivatives and integrals, and I pretty quickly figured out I couldn't do both. So I just picked the derivatives, I learned those. You're picking the integrals.
I feel
No,
like
I
they're the
know how
same
to
thing though.
do the derivative.
They are the same thing.
It's
like,
3 squared.
You're trying to tell
it's
them
like
that.
saying,
A is 3.
we were golfing. What?
It is
Okay,
3.
good. So this is a direct, no, not question. So we need to do a thing here, right? What's different from the other problem?
It's the number.
That's not x squared.
What's hold on, what'd you say, Gabe?
It doesn't have like a range, like it doesn't have numbers.
Okay, it's an indefinite integral. The
And
last one
the
was
x on
actually-
top.
And I do have an x on top this time. Okay, so that's a little bit of a problem.
Not this.
Okay, so I want it to look like that 1 over x squared plus something, right? So that means what I'm going to do is I'm going to let u squared equal x to the 4th.
And then,
Okay, so that immediately changes this into something closer to what we wanted, because I have u squared plus 9. You see the end of the story? So if u squared equals x to the 4th, then u equals x squared, okay? And then du is 2x dx. And so that's why they threw this x in here, because we have an x in our derivative, so we need that x d to the third.
and
So
then
we
put a
can
half
1/2
on.
Okay, so we put a 1/2 outside. And then x dx is this stuff right here, so that just becomes du. Okay, now you can say that a is
Oh, now you.
A is 3. So I'm going to use the formula that we just had. So it's going to be 1/2 times 1 over a. So that would be 1 over 3,
Why are you saying that though?
because this is a square.
We have to square root of that.
We know what it is.
This did a problem and copied down this important formula of 1 over x squared plus a number squared. So if a is 3, right? Because 3 squared is 9. So I went 1 over 3, inverse tangent of x over, u over, the formula says, right, u over a, and a is 3, plus c.
Where's the squared?
But it's x squared.
And then we have to replace this u with
X.
x squared, and I'm going to multiply that fraction out, so final answer,
I have
1/6 inverse tangent of sine x squared over 3 plus c. Okay,
How
fire
did we
away.
just get rid of the x to the square? So like, I'm saying it was x to the fourth before, and then somehow we got rid of part of that.
Because we made u squared equal x. to the
Yeah, I
fourth.
know, but when u squared is plugged back in, x to the fourth is still. We only have to plug in.
Yeah, and the reason for that is, Mary, in the formula, you'll notice that it starts out as an x squared, but then in the answer, it's an x.
Well, I
So,
understand
right,
that,
so
but-
what happened here is this started out as an x to the fourth, and in the answer, it's an x squared.
Oh, okay.
So it just kind of drops down a little bit, power wise. And again, proof is in there. Don't talk to Gabby about it, because she'll just say that someone made it up, but it's real. It actually happened. Okay? All right, are you guys all right with that?
Yeah.
Okay. Assignment, short ones.
That wasn't terrible.
You're welcome, but Mr. Roach is fine.